live and super excited to be kicking off, getting started with live stream number 116 with a very special guest. Before we get into that, just a couple of housekeeping items. We got some stuff coming up as usual. We've got a panel next week. Databases on Kubernetes is going to be featuring various community members, looking at different databases, how they integrate, the different challenges that we face with that. And also, of course, keeping in mind the element of storage, because that's super important too, if we're talking about databases. So you got the link to that right there. Also, our CFP for KubeCon, our co-located event on May 16th is open. The submissions are coming in. We're getting some really, really good stuff. Very happy to see increased quality and that people are listening to us when we say no vendor pitches, no vendor pitches, no vendor pitches. Keep it focused on running safer workloads on Kubernetes. You've got all the information that you would want about that there. Our speaker today has also submitted a talk for KubeCon, so hopefully get that in there too. Anyway, you know how we do it. We always got lots of things going on. You've got all the info there and links. Today's speaker is not the first time he's been with us. And the last time that we had him with us, gave a really, really good talk and had some amazing, tangible, practical examples that I really enjoyed. All right, being able to relate concepts that are very complex. We're talking about graph databases. Today, we're going to be hearing more about Nebula more in depth. But being able to relate these things to everyday things that we're talking about, in this particular case, it was about basketball and different stats about different players. Hoping that comes back today. Our speaker is a little bit modest, and I don't want him to be too modest. You know, I have the joy and fortune of making the Data on Kubernetes rap videos that we're putting out every week. But our speaker today, I think, has been making music about cloud native stuff for even much longer than I have. So without further ado, Wei, can you introduce yourself for the folks who don't know you? Super good to have you. You're joining us from China. What time is it there right now? How you doing, man?
Thank you, Bart. It's 1 a.m. in the morning.
we should be quiet. All right. All right.
Okay. I closed the door of my wife's room.
Oh, okay, good. Yeah, mine's in the other room, but it's 6 p.m. here in Spain, so she's used to this craziness.
Yeah.
Anyway, so for the people who don't know you, can you just tell us a little bit about yourself, how you got started working with databases?
Yeah. Thanks, Bart, for the opportunity, and also regarding the music part, I just play some weird music when I was middle school. I feel privileged to have a chance to communicate with you about the music. And I am a developer in Shanghai, and I love open source. And before I jump into the graph world, I used to work on open infra, open stack stuff. Yeah, and I majored math in college. I feel close with the graph thing, so I choose to change my job, looking for open source opportunities, and then boom, Nebula Graph.
All right, and it was that simple. So the natural sort of connection between mathematics, that definitely made a lot of sense. And your first experience with Kubernetes?
You mean when did I start?
When did you first start working with Kubernetes? Yeah.
I didn't play pretty much of Kubernetes in my work life, but in my nighttime, I used to play it in my home lab, and I'm curious about that. And I was playing the VM as a service. So container as a service is by nature my interest. So I play them as my toys. Yeah.
Very, very good. I think it's a nice way to start too, because maybe a little bit more relaxed and not so much pressure. That being said, if you want to start sharing your screen, we can jump right into your presentation. As usual, folks, this is a dialogue, right? Get your questions in the YouTube chat. We can answer them on the go. If for whatever reason we don't have time to get to all of them, we can definitely continue the conversation in Slack. But of course, be fair to Wei and know that he will respond tomorrow, as it's already 1 a.m. in China right now. So that being said, Wei, take it away.
Okay, thank you, Bart.
Yep.
Share.
Perfect.
Okay, I need to ensure I'm sharing the audio as well.
All right.
Share computer sound. Okay.
Okay.
So
yep, sounds good.
C8. So maybe I can. Should I keep this circle on or off?
No, I think it's nice. I think it's cool. It's fine by me.
Okay.
Yeah.
Okay. So thank you, everyone. We will start. I'm super excited to have another chance, in DoK with Bart to share more things around the graph databases and distributed systems. So we will start. So I already introduced myself. I'm an engineer in Shanghai. I love open source. I used to play with the open infra community. And this is my GitHub, Twitter, my website. And one thing to mention that today my slides is a web-friendly one, and I already put it online. So you can remember this URL and you can check back and forth during my talking. So hopefully it's easier for the listeners. And I have this in the second slide too. You can take a picture too. So the topics today will start from the basic thing around the graph, but I believe you already have a lot of sense on them already. I will go through very quick. Then we'll give some more detailed information on how Nebula Graph was designed and the architect, and why do we need yet another graph database. There are a bunch of them. They're out there already. We already know. And then we will, to help us to make more sense of what Nebula Graph or what a graph database really are and why they are there. We'll go through some know-hows, and I will show you some toy projects with some demos. Hopefully everything goes well. And in the end, we are data on Kubernetes. Nebula Graph is naturally was born in distributed way and is cloud native. So I will give some more information on the operator, our Kubernetes implementation. And I will share a toy project to help you to access that easier. I will share that in the end. So we will start. So what is graph? What is graph database? Why yet another database? I think we already talked about that in the last session with Freeman. So I will go through very quick that graph in mathematics refers to those dots and those connections. So basically they are just vertex and edges. And that's why the team behind Nebula Graph is called Vesoft. V refers to vertex, E refers to edges. So this is definition of graph. So we will know why we need this kind of definition later, I believe. So what is a graph database? So graph database is a database that's persistent data in the form of graph, which is the vertex and edges, or we also call it nodes for the vertex. And in most of the graph database, in general, we have a new concept called property graph, which is a definition of the graph on top of graph. And we add something called properties, and you can understand them as the key and value. So you can add key and value in either the vertex or the edges. So that is basic what a graph database is all about. And why do we need that? So this slide is reused from the last one. I will go with real quick. And the first perspective is regarding the schema. So it's not a very large, but I will explain. So in the left side, it comes from a picture representing the schema or the definition of data for a tabular database, a typical relational database. So you have something like some table named person, some table named corporation, and these are entities of the corresponding table names. But when you come to when you want to represent the relationships between the two tables, like you want to have the role relationship between a person and the corporation, you have to create another table that may be named the role relationships, and to stand for the relationship, like someone is playing some roles in another corporation, something like that. So in theory, you can do that for all the time, but it's not that flexible when it comes to a scenario that we care a lot of different relationships and it changed day by day. So like when you are introducing yet another new relationship, there comes to the schema change and some data, some existing data should be rewrite. So that's quite you know, not that flexible. But the graph database was born to solve this kind of issues. And we define the schema, or we define the data in a way that's relationship oriented. So you can just define the way it the human brain is understanding that, just like this. So another issue is when you want to query information like you have a table named the basketball player. You want to query the given player. You want to query all the other player that serve exactly the same team. So this query in graph database is like a one jump query, and it can be done in this way. But in RDBMS, it's one jump will be something like this. You have a couple of joins, so it's kind of disaster. But when it comes to multiple jumps, it will be even worse, obviously. And the deal maker actually is the performance. So graph database will persistent data in a way that's oriented, the connection oriented. That means when you query multi-hoop, it's quite cheap. And when it comes to high throughput, high concurrency case, it will be worse. The situation will be make a lot more difference between the two model of database system. So this is just a reference that there will be like 100 or more times differences. So this is the key point, that a lot of scenario can only be done by graph databases. So that was all slides. But when I was preparing for this presentation, this awesome talk.
Oh yeah,
I want to make
and it's already awesome. We're already breaking records. This is amazing. Keep going.
Thank you, Bart. I want to do more to make us easier to understand it. So I make some metaphors. So the first one is, you know, you can detect why between the two queries from this awesome guy's face, and we love the meme of him, right? The other one is a retro game. So I am old enough to play the NES when I was a kid. So, and I noticed that the awesome Kelsey Hightower. So when he initially introduced the Kubernetes in one of the KubeCon, if I recall correctly, to show us how Kubernetes is working and how Kubernetes can help. So I go through all the virtual games I can see to find this. Maybe the metaphor here is inappropriate, but I hope it somehow will make some sense. So in this game, this is game called named Snowman Brothers. So they are the brothers is helping to kill the monsters to save the princess, and they have to jump from one layer to another layer. So in this metaphor, I somehow in a wilder way think maybe the layers can be mapped to the data tables. So in a tabular database, you have to jump from one to another. When you want to query the connected, sorry, I died in the initial. You have to jump from here to here, and you have to scan in some distance to find your data, and that's one hop. So in some real case, and you can optimize them, like you have the very fast lag, and that can be mapped to a case that you create some sort of indexes, you make some optimization, but it doesn't really help in the next level. So you can see you can be very fast like this. You create a lot of index, but still you have to go through between the tables like this. But what is graph database look like? It looks like this. So this is the green bottle. To enable, you can literally fly in the whole screen, and that means you can jump from one point to another point directly without scanning any index or data itself. You can directly kill this monster just like this. So I think that is the maybe not that straightforward, maybe an inappropriate metaphor between the difference of the graph database and the tabular graph database. And there is a saying that the relational database is actually not good at dealing with the relationship. So I hope it makes sense somehow on the, how
it makes sense. And I love that. And you can bet that we're going to be using this. I'm tweeting this right now. Really quickly, apart from this game, because maybe we can think of other, not right now, but do you have just a comment really quickly, your favorite NES game?
My favorite will be, I don't know how to say in English. It's the football, but it's it's a Japanese game. You can kick each other and still play the football. I'm not sure if you know that game.
I think it sounds familiar, but I'll have to look it up. That we can share that later on. But anyway, I'm a big fan of classic arcade games as well as NES. So this is a great example to be able to see the differences. Anyway, loving it. Keep going.
Thank you.
Yep.
So we know that in certain scenarios, when we care about multiple relationships, so we know that graph database should exist, and how popular they are already now. So we can check from, this is the URL, but you can check from yourself, DB engines, that it's showing that, from one perspective, it's a marketing thing. Graph database is really in trending, and even in one perspective, it's the most popular kind of database. So I'm not going to show this now, but you can check that. Okay, then we move forward. So Nebula Graph. So why do we need yet another graph database? And you can check more from this URL, right? So I will, before we move on, I will give a brief introduction of what it's like for Nebula Graph. So this is a page from the documentation of the Nebula Graph, and I will give a brief introduction of its architecture and design. So Nebula Graph was designed in day 0 to be distributed. So, and the way it's designed is it comes with 3 kind of services, which are the storage service, the meta service, and graph service. So the storage service literally persistent all the graph data, and it used the Raft to ensure the data high availability and the replica, and the graph service is actually stateless, and it's the service that handling your queries and parse your queries and make the plan and call the storage to make all the data fetching and manipulation. And meta service is in charge of all the meta information, like the credential and how the data was distributed around the different hosts. And you can put all the services in any way, so it's very flexible, and you can tell that it's designed in a service, in a computation and storage in a separate way. So that, and this design, I'm not going to deep dive today. And this design had enabled the Nebula Graph to be very good at handling the scalable data in a huge volume of data, and I will show that later. And next slides. So the main reason that a lot of users told us that why they choose to use Nebula is because in certain scale volume of data, only Nebula Graph can handle it, or only Nebula Graph can handle it in such performance. And I want to quote one of the tweet. I saw it last year. So this is a ship is blocking in a small river, and the two guys are trying to make it right. And another case is the famous one, you know, I don't recall the name of this ship, and it impacted the world in last year for a couple of months. So it looks like similar in some way, but the way you are dealing with the thing will be significantly different. So scale makes differences. So and Nebula is good at scale. And another reason that Nebula Graph exists is it's open source. And with the help of the community, Nebula Graph in the very initial phases, when it's not that mature, the community users help us to prove that it's working and it can be working fine. And the power users is teaching the community and how some really good scenarios that you can improve, and you can do this in a next level way, and they help us to evolve really good. So Nebula Graph, the project of Nebula Graph was initiated in 2018, and in 2019 December, we already have our very first production cluster deployed. And actually, when it comes to 2020 June, we have our very first GA release, and we have our 2.0 GA last year in March, and we will have 3.0 in coming months in March or April, if I recall. Yes, and there are already a couple of a bunch of giant teams in different different industries is adopted Nebula Graph in their production, including a lot of giant team that dealing with a huge volume of graph data, like Meituan, which is the Chinese version of Yelp, like Tencent, and like Akulaku, WeChat, and Huawei, and a lot of was not added here. Like last week, we came to know that Tencent Music, which is the Chinese version of Spotify, is using Nebula Graph, dealing with their knowledge graph. Like by Baidu, last month, they shared their experience that they are using to manage their huge amount of user profiles, and they are doing the ID mapping thing with Nebula Graph. And they are doing really good jobs. And you can check the ranking here in DB Engines. So most of the Nebula Graph users now are in Chinese, most of them. So when DB Engines are making this ranking, so you know they are counting on Twitter, LinkedIn, which most of the Chinese developers or companies are not using. So we already in a very front ranking. So we are working on the we want to promote or develop, advocate our user to all over the world from this year. So I hope you can check out Nebula Graph and check out the community. Yeah. Then let's move forward. Yep. Yeah, and Nebula Graph is already with a very rich ecosystems, and there are a bunch of sub projects all over the community. Like we have in the cloud and the observation monitoring fields, we have a bunch of different projects. We have the cloud, the graph algorithm, graph computing, open source projects, and the data import. We have importer exchange, which can make like more than 10 of different sources can be exchanges with the Nebula Graph. We have a bunch of different SDKs, and at the end of the last year, we have a couple of community users donate their contribution on like Nebula PHP, Nebula Node.js, and Nebula .NET, not listed here. So the ecosystem is quite mature, but we are still working on to make it better and better every day. So yeah, welcome to check out Nebula Graph community. So marketing part is mostly done. I will show you more graph things from now on. So this is, we will introduce something around the use cases of how graph database can help our in real life work. So I take this samples from a couple of use cases from Meituan, which is the Chinese version of Yelp. So very first one is it's an intelligent agent. Like you can from the app you can request in your natural language, like, is there any McDonald's nearby the street food bar? So underlying the graph database is helping Meituan to make this thing work, and I will demo even a similar project later on how the dots were connected. Another thing is more interesting to me is like when you are surfing the different restaurants in Yelp, you want to know choose some nice fancy restaurant you want to have this for this dinner, and sometimes the system will give you some recommendations based on very complex algorithm. But in the recommendation systems, the explanation of the system is somehow quite tricky. But you can get that help with the Nebula Graph or graph database. So this is a sentence in the searching result, namely those whom from Beijing enjoyed Korean cuisine said this restaurant is great. So this is kind of explanation of why this restaurant was ranking high. So, and under the hood that Meituan shared, they make all the people's the profiles of the people in different perspective, like where they come from, and they in history they enjoy which type of restaurant or cuisines. They make everything in a huge knowledge graph, and when they have the recommended results, they just make a find the path of this graph like this. And when they have a path, and they make this path into a human readable sentences as the explanation of this recommendation. So I think this is a very cool example that. So for Nebula, for graph database, this is quite simple query, but in the recommendation system, the performance is quite good actually. And there are actually the similar case that the graph database can really help. There are more than 10 of typical use cases, which is kind of very mature, but like the social network, obviously, and the risk control, you can detect the fraud in real time with graph database. And you can check the people that's you can check the people in the public security domain, and the knowledge graph. If you put a knowledge graph in the graph database, you can have multiple hoops query really quick, and there are some machine learning plus graph text fields, and in some of the cases you can leverage graph database. And I'm not going to name all the scenarios, but I will give some of them in the following of the talk. So, so the first scenario that I will dive into, and I even open source the code, so you can play it yourself, is regarding the host sharing relationship analysis. So in China, we have a website that almost everyone knows that you can, before you are joining a company, you can search on the company on who is actually sharing the host share of the company, who is behind, and what is the other corporation is sharing with this corporation. So this kind of website or regulation system can be done with a graph database quite easier. So I created a toy project based on a fake data named corporeal search. So you can check out the code here. I will demo more of it and show you how the graph database is helping on this kind of a system and how it was designed. So before everything was thrown, I will go start with the graph modeling on how this kind of problem can be modeled in a graph way in Nebula Graph. So this is the this is the graph module I showed them before when we were comparing with the RDBMS. So in this graph, we have two kind of vertex or node, which is the person and the corporation. So in person, you have in front of name and age, and in corporation, you have the name and location. And there are also, there are also relationships between them, or we call it edge. The person can hold share of the corporation. Another corporation can also hold share of the corporation. And the person can work as any role in the corporation. And the corporation can be a branch of others. So this is a very simplified module, but can somehow reflect the problem, I hope so. And with this data was defined in a graph database with Nebula Graph, you can use this query. You can go from 1 to 3 steps from this corporation over all kind of edges by direction. With this query, you can do something like this. So you can, from this corporation, you can find all the hidden relationships between all the persons and corporations in a visualized way. So this is the interface of Nebula Graph. So with this kind of graph info constructed, so what we can do more to make this more like a system. And I will give more information on this project. So start from the architecture part. So it's quite straightforward, just like other websites system. You have a front end, back end, and your database. And in this case, we use graph database as a database. So front end in this project, I use Vue.js and D3 to render, manipulate and render the information of the relationships. And I will make it more sensible for the human beings. And the backend is handling the request of the API from the front end and make the queries to the graph database and make the graph data and assemble the data that front end can understand and return it. So quite straightforward. So the code is quite simple. So this is a simplified code of this logic in the backend part. So you can see when a API call is coming, and you can handle this from this function, and this function is making this match query, which is a graph query in the OpenCipher. And it's actually help you making the relationship that user cares, and will be sent to the graph database. So then we will move on to, this is related, this slide is related to the fake data that I create. It's also open source, and I created this data to, you cannot use the real data to do this kind of things. So I shared how I generated this data with a very random rows and names. and how I import the data into the graph database. So you can check out to my article, my blog, and my GitHub on the corresponding tasks. And this is showing on that leverage Nebula Up, which is also a utility open source. You can spawn a whole bunch of the graph database plus the Nebula Graph Studio, which is the GUI projects together in this one line. So with this setup, we can start up the, we can start the real code part. So I will demo it, and the code is here. Okay, hope everything will go well. It will be very short. So I will show you the code. And I'm running the backend here in Python. And this is the front end, and I'm using Nginx on my desktop, and front end is localhost this port, and I will show you in this. Oops, it's open. Okay, and we'll start with any corporation. Enter. Boom. So this is the toy system that you can help user to find given person or corporation. You can find all the relationships that you cares regarding the role working in the corporation and the corporation's different relationships. So isn't that quite cool? And this is the data that's returned. You can see this is the data written from the graph database, and you can see this is the result, long result. And you can see the query here. This is the graph query. So this is the very first case. I walk you through very quick, but you can check out the code, all the detailed codes from the GitHub to look some more details if you are interested in. So, and I also put a demo video here in the slides, but I already demoed to you, so I won't play it here. So then we come to the second use case, which is I call it Siri. So it's similar, to the other agent. So it's a dialogue system that you can answer your questions intelligently. Maybe not that intelligent because I make it it's a very toy level project. So the code is here. So we'll go through it. So we will first go through the graph modeling, but I will skip this part because this robot, this Siri, is actually only can answer the question related to Tim Duncan, as Bart shared. So it's
yes, Tim Duncan, perfect.
Yes,
let's do it.
Yeah, yes, and the data behind the whole system, I already demoed it before, and you can play it anytime in this demo page. So there will be a couple of playgrounds set up there. You don't need any credential if you only have a browser, and you can play with the Nebula Graph with the Tim Duncan data set. So I won't show you, but if you not see it, you will have more idea on the following demos on how the data was shown there. So one thing is that, and in this data set, you have a couple of players and a couple of basketball teams, and the players can follow each other, and the players can also serve in the certain teams. So there will be a simple graph, and this system is actually a voice agent. You can ask something like, how does Tim Duncan connected with Yao Ming, or what's the relationship between Yao Ming and the Onion Shark, something like that. You can handle a couple of different type of questions, and the whole system will do the job for you. And I will dive a little bit dive deep with that. So it's similar to the other projects. You have front end, back end. So I will give more information on the back end side that in a typical system that handling the dialogue, you will have something called intent matching and semantic processing. So in this part of code, you will pass the sentence that user sent to you, and use the intent matching and the semantic process to classify what kind of intent or you want to ask, like you want to check the relationships. So this part of code will classify it and parse the information when you want to check the relationship. You want to check relationship between A and B, you will pass the A and B information from the sentence. And that's what the classifier do. And all the code is open source here, you can check. But actually here I'm using the if and else. It's quite silly. But in the real world, you can do that with the NLP technology, with machine learning. But as I know that when I was checking with a lot of users, in certain cases, the if-else is actually quite performant and efficient already. Like in the hospital, you want to question which room I should go to check with doctors. I have this symptoms. So if-else is enough in those kind of situations. And then with the intent and the entities, which is A and B, you will send them into the actor of intent actor part. So intent actors will assemble your graph queries, and similar as the last project, and send to the graph database and handle the results and send back to the front end. So this is the code structure. I won't go through all of them. And then we go to the demo part. Actually, I make the whole end-to-end thing from the graph database setup, the data importing, and the backend, the front end, everything, and even the ingress, sorry, NGX, the load balancer, everything step by step. I already create a Kataconda playground, so you can actually check out this, and by clicking your mouse, you can actually play with the Siri on your own browser. So and going during that, you will learn more of what the knowledge graph-based Q8 system will look like. And here I just play a demo I recorded before. So yeah, oops, it's not that qualified. Okay, I hope it looks better. How does Team Duncan and Lakers connected? How does Team Duncan and Lakers connected? Okay, boom. Yeah, and that works. And underlying the query and how the data was connected was already demoed in last talk in DoK community. So I won't show that for you, but no, this is how it looks like. And I hope you will understand more on graph database, was helping on this kind of agent. So the next one and the final project I want to share is about the data lineage, or the metadata management system. So this one is not actually not a toy project anymore. It's an open source project initialized by the Lyft data team, and they donated to the Linux Foundation. And it's quite refreshed and yet already quite mature from my perspective. And I will give you a demo and more introduction of this project. Maybe many of you already know that. And in the end of last year, I was doing some work to make Nebula Graph as the backend of Amundsen, but it's not yet open source to the community. But hopefully I will open source that in upcoming months. And this is the website of the project, so you can have some brief concept of this project. So basically, Manson is a metadata system that it can manage all of your different data sources, like your database, your workflow, airflow system, your data lakes, and all the metadata, like the table, the schema, the column data of all across your company. And in certain case, when like you want to change the schema or you want to delete a database, you don't know what's how many consumers and how it's related to other systems. So with this kind of system, you can manage them all, put them together, and you will get all the insights of the relationships and how they were used. You can have the statistics of all the different table, different data sources. So I will have more sense in the later demo, hopefully. And this is the what's Amazing look like. I will have a live demo later. And we will start with the data modeling first, but you can check from the Amazon documentations as well. This is a simplified version. Like in this module, you will have the database, like you have the Dynamo, the Hive, the CRDB in your data lake. And the database can have some cluster instances, and you have a production one cluster, your staging one cluster, and each cluster can have a couple of different schemas, and each table belongs to one schema. So is that making more sense to you? And the table has different columns, and table can be used by users. So this is the real user of developer, data scientist, the data administrator. And you can have a lot of DAG in your Airflow system, and the DAG can write to specific tables, and the tables can be owned by users, and you can tag your tables, and the table has descriptions and has and the columns has statistics, like your specific applications will consume this data in a different frequency. That can be also managed by this kind of system. But there is a lot more of them, but this is a simplified diagram. And then I will introduce the architecture of this system. So the Amazon will communicate with all the meta sources of different data-related systems or databases or applications. And there will be a service named the Data Builder, and this is actually just a Python library that you can run with your Airflow or even serverless functions like Open Functions or Google Cloud Functions in your infrastructure. And every time you run the jobs, you will pull the corresponding data from different sources, and you will ingest them in your graph database. And also you will build the index in Elasticsearch to enable your wildcard search. And there will be a meta service that's just like the backend service in previous projects I shared. It will take the API calls to query the metadata from database. So this layer is making it decoupled with the different kind of graph database as backend. So Amazon is open source and it's not binding to any databases. And actually it even supports RDBMS, but the performance and the scenarios was very limited in that case. So in front end, we will have the fancy user interface. And these are the corresponding code It's using a mono data. So you will have all the code in this single repository here in GitHub. And then I will give you some demos of this system. So this is the front end. So you can actually search anything. So this is elastic backed, and we will have all the components of this metadata. And for example, it's this table is comes from the test schema, and the table name is test table 1, and it's actually a hive, and it's tagged in gold, and there are a couple of owners here. Now you can see it's last updated. The schema was updated in this time, and you can check the frequent users, and you can see it's all the columns. Yes, all the columns, and you can modify the owners here. And for the columns, you can check all the related system in this interface. And you can see the downstream. So this is important. This is related to the data lineage. Data lineage is referred to how the multi-hoop relationship between the data, the table, the application, the jobs, and the user, how they are related, and you can know why, who break this, and if I can manipulate this table. And this has a very fancy UI, and you can even check the in lineage in a visualized way. So it's quite cool, right? And then I will, Then I will demo this data in the Graph Studio, just like the basketball player we did last time. So in this view, you can see that this table have a lot of different relationship with other components, and you can actually see. I'm going to. Okay, this table Dynamo. This is Dynamo database has a cluster named Gold, and Gold has a schema named test Gold. And from the Graph database, you can double click to check, oh, there is a table instance on top of that. And you can check all the related information. And this table was consumed by this Airflow jobs. And this table was actually generated by another Airflow jobs. It's consumed by another Airflow jobs. So this is the ability that we could do when we put Nebula Graph as a backend of the Manson. So apart from the ability that I already showed you on a queryability, the schema, flexibility, and the performance of the Graph database comparing to a tabular database, and normally most of the Graph database come out of box with a fancy usable visualized tool, and that makes difference from my perspective. If you are only making a meta governance system, and your ability sometimes is limited by your meta service or your backend service, you have to define specific API to enable certain kind of metadata relationship check. But in case you are using a Graph database or even a Graph database like Nebula, you can have naturally the Graph query interface is your DSL or your yet another powerful interface that can be used by a non-Graph database expert, but they can still have the flexibility to query different kind of variety of insights between the different data, without introducing the loop of introducing another version of API and testing the API using a new API. You just expose the needed read permission of the Graph database, or even the Graph database with a visualized tool. You can like the expert, the data expert to explore the insights directly in this way. So that's another angle that's graph database helps. And then the final is I want to show you, give you more sense of the query underlying of the system. So this is the code of Nebula Proxy. So it's a submodule of the meta service part. So Nebula Proxy is using to decouple, to making all the works related to Nebula Graph as a backend. So this is a query of table information. And in the real world, the query will be something like this. And it's something like you want to query from this table with this ID. And you want to, in one query, to query all the relationships related to different angle of relationships in multiple hoops in just one query. And I will demo you. So in RDBMS, it's not even possible in real time normally. So, but in Nebula Graph, you can do that in no time. Boom, you will have the very complex result in no time, in real time. So it's just a demo. And at last, I will share you something regarding our Kubernetes approaches. So which is Nebula operator. So we involved all the way from initially we don't have a cloud engineer in our community. So we just put a Docker Swarm, Docker Compose in the projects. And afterwards, we have a Helm implementation, but we all know that Helm is not a best fit for the stateful workload. So eventually we adopted the cluster, the operator module, and we leverage the Kube builder to do that. Oops. And actually, with the Kube builder, we make the code very clean. That in the API part and the config part, we creating the CRD named the Nebula clusters. You can define a Nebula cluster in like 20 lines of YAML, quite easy. And the controller part is actually, the control loop that check your states and your configuration. And if something is changed, it will reconcile to make the thing right. So the code is here. And the Nebula part is apart from reconciling the resources inside the Kubernetes cluster. And sometimes you have to deal with the Nebula cluster itself. You have to call the Nebula cluster in the ngQL query language. So that will be the Nebula part here. It will call something regarding the data balance, for example, here. So for more information, if you're a Kubernetes expert, welcome to our community. So this is the code is open source here. So we are far from mature on our operator, and we are eager for the contributors if you are interested. And then I want to introduce a tool I created called Nebula Operator Kind. So it's a small tool help you to set up Kubernetes in Docker, which is named Kind. We all know it. And then we will place everything up in this Kubernetes inside the Docker, just in one line. So after you query this line, you can access the cluster very easy. And you can, for example, you can then access its console with this line. So the console was also handled by this tool that I created. So it's very handy. So if you are interested in Nebula Graph on the Kubernetes, you can use it in this one-liner. And then you can import the basketball data source in two lines. You just wget data source and then use this line to import it. In like 2 minutes, the data will be ready, and then you can play with it. So this is the documentation of the sample data. So yeah, I think we finished all topics. So let's brief recap. So now I think we know from the, the Snowman brothers, we know why we need a graph database. And from the shape, we know that Nebula excel at the scales, and in the huge volume of data, Nebula come to this scenario is for you. And on how to, we walk through three projects as an example. We have a corporeal search, we have the Siri. You can ask him about the Tim Duncan, and leveraging the great, awesome Linux Foundation Amazon. You can manage the metadata in a quite fancy way in the interface. It also comes with the API, and it supports defactor all the different kind of metadata sources already out of box, and it's a very active community. And then finally, I introduced something around our approach on the Kubernetes Nebula operators. And check out my GitHub, my Twitter, and my blog. And this is the URL of this slide. It's fetchable from this URL. And I want to thank you. And before we call this the end, I want to share more about our community. So you can, if you are interested, you can register our community meeting. And we have a Slack channel. And we are doing this bi-weekly around this time, depending on different time zone. And one news I want to leverage our awesome DoK community. I want to share one announcement that today, I just updated it before we start. Nebula Graph announced our as a service, managed service cloud on Microsoft Azure today. So you can feel free to check it out. It's in open beta in the first month. And yeah, welcome to check out our GitHub repo here. And that's all from my side.
Pretty good stuff, and very, very exciting news to see that the open beta with Microsoft Azure. Wei, I don't know where you learned how to do presentations, but you either had a very good teacher or just naturally are extremely gifted. So good. You cover so many different topics in the span of an hour, and we get the full, the full experience, and also really seeing what makes this database different. And what I really like is just how visual it is. And brings these things to life that sometimes can be a little bit difficult to read or difficult to understand, but it just projects the information in such an easy way. So at the end of the day, it's not about data, it's about helping people make better decisions. And so when you get to see things, at least for me, perhaps I'm more of a visual person than others, but I really, really enjoyed it. Interesting to hear as well too about the work that's being done on the operator. Folks, if you want to get involved, you couldn't have a nicer person to help you get onboarded. So definitely reach out. Wei is very accessible. Twitter, LinkedIn, Slack, etc. So there's no excuse to be shy. Just jump in and start asking questions. That being said, one of the things I wanted to ask, or that we're asking all of our guests, is we talk about, what is data on Kubernetes? How is it done? But then also the question of why. All right. And there are different benefits that some people might reference, that it's better to have all the technologies in one stack. That there could be cost saving advantages, that there could be different benefits of running a database on Kubernetes. In your particular case, in your opinion, what do you think? What do you think is the best reason as to why people should consider doing it?
I really love Kubernetes. I think if possible, we should, and if you are running infrastructure on your own, you should put things on Kubernetes. I think we all know, we all hate, a lot of people hate Kubernetes, but a lot more people hate Linux. But I think Kubernetes make the essential abstractions. I think the most valuable thing in Kubernetes is the API itself. Maybe like 5 or 8 years later, we don't need a so-called Kubernetes of today now, but the abstraction and the idea behind the abstraction to save the day, and you can have a better sleep. Everything is in the loop. You take the people outside of the loop. I think that's the most valuable thing. And we have the serverless modernization way. Maybe in the future, most of people even don't know details of Kubernetes. Not like today, they care about more on serverless. Maybe, or even some more even more crazy, or you have to deal with the no code case. But I think in today, Kubernetes is still the go-to solution. And that's my thoughts. Yeah.
No, I think it's a great point. I think it's a great point. Now, can you stop sharing your screen really quickly so I can share?
Oh, yeah.
Because you know what's coming. You know what we're about to do.
Yes, this time I know.
No, just because I was just checking out your website right now, and I'm going to link it right here in the chat so folks can check it out directly. And so the slides for today's talk will be uploaded on there, but Wei's got lots of good resources on here too. So definitely check that out. Like I said, I just dropped the link in the chat, so you'll see that in a minute. But that being said, one of our favorite parts of the live stream is where we get to share the artwork. All right, so here we had our amazing artist Angel in the background. Angel, by the way, is a big fan of yours. He was talking to me while this is going on. He's like, this is so interesting. And also because Angel's an artistic guy, so to see these things brought to life, both with your slides, but also with the graph database itself, in terms of how we get to see things. We love the video game reference. You can never have enough, original Nintendo NES. That was great. I'm going to check out that Japanese soccer game, by the way. Tip, we got you in, Angel decided to draw you in a Spurs, so we could represent Tim Duncan a little bit too. Anyway, plenty of good stuff. Wei, it was such a pleasure to have you. I hope we'll be able to have you again in KubeCon. Remember, folks, you can submit your sessions for KubeCon in the CFP that we linked. And if not, jump into Slack. Talk to people like Wei. This is what this is all about. Celebrating community, meeting people from different countries, people from other countries that make sacrifices and stay awake until 2 o'clock in the morning to do these talks. But it's the magic of doing it live. So Wei, thank you very much. We'll be talking soon.
Thank you.
All right.